All right, let's look at question number 24. One card is drawn from a standard 52 card deck. Now, I'll put the breakdown of a deck of cards on the board for you for the test, so you don't have to worry about that. But what is the probability of drawing a 4? Okay, so there are 52 cards in a deck, and out of those, there is a 4 of hearts, a 4 of clubs, a 4 of diamonds, a 4 of spades. There's one in each suit. So there would be 4 4s out of the 52. And then we would want to reduce that down to its lowest terms, 1 out of 13. All right, then B, the probability of drawing a 4 or a black card. So remember, when you have or, it's the probability of the first one plus the probability of the second one minus the probability of anywhere those two things intersect. So that would be the probability of a 4, which we just had a second ago. That was 4 out of 52, plus the probability of a black. So there are 52 cards in the deck, and half of those, 26 of the 52, are black. But then we need to subtract off any cards that are 4 and black. So there would be a 4 of clubs and a 4 of spades that are black. There would be 2 cards out of the 52. And again, the reason for that is over here, when you counted the 4s, you counted the 4 of clubs and the 4 of spades. And here, when you counted all your black cards, you again counted the 4 of clubs and the 4 of spades. So this is subtracting off that duplication so that you don't list the same cards twice. So when we subtract, we'll get 28 out of 52, and that reduces to 7 out of 13. All right, then for C, we have the probability of drawing a black 4. Now, that doesn't say and in it, but if you think about it, if it's a black 4, is it black or 4, or is it black and 4? Well, if it's a black 4, it has to be both of those, right? That's an and statement. So our formula for and is the probability of the first one times the probability of the second one given the first one. All right, so let's start with probability of black. So again, that's 26 cards out of the 52 cards times the probability of drawing a 4 given that you know it's black. That given changes your denominator. If you're saying given it's black, you know it's black, that means that you only have the 26 black cards to choose from. And out of those 26 black cards, only 2 of them are 4s, the 4 of spades and the 4 of clubs. All right, so then 26 over 52 reduces to 1/2, and 2 over 26 reduces to 1/13. So when I multiply, I'm going to get 1 out of 26. Now, you could also just use common sense for this problem and figure it out with logic if you wanted to. If you're saying how many cards in the deck are black 4s, well, like we said, there's a 4 of clubs and a 4 of spades. There's only 2 out of the whole deck of 52, and again, that would reduce to 1 out of 26. Now, in just a minute on question number 26, they're gonna ask us if two things are mutually exclusive, and the answer is going to be yes. So I wanted to also give you an example of two things that are not mutually exclusive. Mutually exclusive just means that they have nothing, no outcome in common. Their intersection would be 0. So can you have a card that is a black and a 4? Well, yeah, we saw that right here. So they do have an intersection. They do have an outcome in common. Their intersection, as a matter of fact, is 2 out of 52. It is not 0. So those two things would not be mutually exclusive. All right, for 25, we're drawing 2 cards this time. 24, we were only drawing 1 card. 25, we're drawing 2 cards from a standard 52 card deck. And we want to know the probability that the first card drawn is red and the second card drawn is a spade. And we're going to look at that with replacement and without replacement. So let's start with replacement. If it's first card red and second card spade, then we're going to do our and statement. So that would be first card red times second card spade given the first card was red. All right, so first off, I draw 1 card out of the deck, and we're saying what's the probability it's red? Well, there are 52 cards in the deck, and 26 of them are red, so 26 out of 52, or 1/2. All right, then I put that card back in the deck because this is with replacement, right? So I put that card back in the deck before I draw my second card, and so then we say, what's the probability the second card is a spade, given that the first card was red? Well, the fact that the first card was red is completely irrelevant because I could put it back in the deck, right? So the second card being a spade, there are 52 cards to choose from and 13 of them are spades. So that would just be 13 out of 52 or 1/4, and so I would multiply and get 1/8. Now, they asked me in the C part down here, are these dependent or independent? And our definition for independent was if the probability of the second card being a spade is the same thing as the probability of the second card being a spade given the first one was red, then they're independent. Basically what we're saying is this first card being a red has absolutely no effect on the probability of this second card being a spade. So if this first card being red ends up being completely irrelevant, it doesn't affect the probability. The probability with or without it would be the same, then they're independent of each other. All right, now let's go back and let's look at that same thing, only this time without replacement. So first card being red is still 26 out of 52, but I do not put that red card back in my deck. It's still laying on the table when I go to draw my second card. So I only have 51 cards to choose from. Now, that first card was red, so I still have all 13 of my spades to choose from, but it's going to be 13 out of 51 instead of 13 out of 52. So this factor changed, the first card being red, changed this probability that the second card is a spade. It's 13 out of 51 instead of 13 out of 52. So for that reason, of course I'd multiply these to get my probability, but for that reason, since the probability of the spade is not the same thing as the probability of the spade given the red, this changed it. So that means those two things are dependent. One of them is affecting the other. It's changing it. All right, then 26, a bag of M&Ms has 8 red, 4 orange, 12 blue, 5 brown, 1 yellow, and 6 green M&Ms in it. What's the probability of A, drawing 1 green? Okay, so I'm going to look, if I go through, I've got 8 plus 4 plus 12 plus 5 plus 1 plus 6. So that's going to give me 36 total. And out of those 36, 6 of them are green. So that would be 6 out of 36, and that would reduce down to 1/6. All right, then for B, what's the probability of drawing 4 green? So this time I'm drawing out of all 36 of them, and I'm not choosing 1. This time I'm choosing 4 of them. Order doesn't make any difference. Doesn't matter which one I draw first or last. So that's going to be a combination. I have 36 to choose from, and I'm choosing 4. That's the total number of ways that this could be done. All right, then for my numerator, I'm going to do, I have 6 green to choose from, and I'm choosing 4. So I put this into my calculator and had it reduce my fraction down to lowest terms. All right, so then for this guy, what's the probability of drawing 4 green and 8 blue? Okay, so this time I have 36 to choose from, and this time I'm choosing 4 green and 8 blue. That means I'm choosing 12. So for the 4 green, I had 6 green to choose from, and I'm choosing 4. And for the 8 blue, I had 12 blue to choose from, and I'm choosing 8. All right, so again, I put this numerator, I put this whole thing in my calculator, and it gave me a decimal in scientific notation, which is perfectly fine. But if you prefer to have it in a fraction form, I just did the numerator and the denominator separately. Now, obviously, this would reduce down because it ends in 5 and 0. But when you put this whole thing in your calculator to reduce it, it again just switches it to a decimal in scientific notation. All right, and then last are drawing a green and drawing a blue mutually exclusive. Well, when you draw an M&M, it can't be blue and green at the same time. They have no outcomes in common. It is one or the other. So yes, those two things would be mutually exclusive.